Right on this, you're asked to figure out how fast a box is traveling that stays in the air for 8.5 seconds is going, and then how high it travels. So you have to do this with kinematics. So start with your initial velocity, your final velocity, your distance, your acceleration, and time. So if you draw yourself a little picture, if a box flies up, it'll move up, then it'll eventually slow down, and then it'll travel back down, and again hit the floor. So your total height in the vertical direction is going to be 0, because you start and end at the same spot. So, since gravity goes down, we're going to say that acceleration is negative 9.8 meters per second squared, and that we're looking for our initial velocity, and that our time is 8.5 seconds. So for this one, all I have to do is use d equals VIT plus 1/2 AT squared, and plug in our numbers and figure out what we have to solve. So if we plug in 0 meters equals initial velocity times 8.5 plus 1/2 negative 9.8 t squared. I will subtract that one of these two values, either this one here or that one there, from 0. And what that will give us is that our initial velocity times 8.5 is going to be equal to 1/2 times 9.8 t squared. And we know t is, again, 8.5. So all we have to do is plug in our values in the calculator. And if you look and see that we can initially cancel one of those two out, and that's going to give us 4.9 times 8.5, which is going to be around 41, I believe. Let me pull a calculator up right quick and check it for you. Yep. So that initial velocity will be 41.65 meters per second. Now the second part, what we have to do is to then figure out how high it goes. So let's clear that. Now we have to do a new kinematic problem for this. So we start with our variables, VI, VF, D, A, and T. Where our distance is now what we're looking for. Our acceleration is still negative 9.8 meters per second squared, and our velocity is going to be 41.65 meters per second now. Now, if we're asked for how high it goes, we start at the ground, we're going up, then it slows down till it stops up here. And it stops moving up because our final velocity reaches 0 meters per second. So, knowing this, we can figure out our distance. Now, you can assume that the time can be either half of 8.5, or you can not worry about it and use the formula that VF squared equals VI squared plus 2AD. And that's what I'm going to do here. So, my VF is going to be 0, so 0 squared is, again, 0. VI squared is going to be 41.65 meters per second. We want to square that value plus 2 times negative 9.8 times D. And we want to solve for our D here. And again, let me pull up my calculator. So it's going to be 41.65. We're going to square that value. And then we're going to divide that by 2 times 9.8. And we find that a D, our distance, is going to be 88.5 meters. And that's how you do it.